solve a system of linear inequalities given a context. To begin with, a system of linear inequalities is a set of two or more linear inequalities. So an example could be something like 2x plus 3 is greater than y, or negative x plus y is less than or equal to 6. So we have two or more linear inequalities that are going to be graphed on the same coordinate grid. And then our solution is the region of the coordinate grid that satisfies both inequalities. So we're going to do a couple of practice problems where we write our own system of linear inequalities given a context and then graph them to figure out our solution set. So for example one says you can only work up to 25 hours each week. So we have a maximum of 25 hours that we can work. At your babysitting job, you earn $15 an hour. At your tutoring job, you earn $20 an hour, and you need to earn at least $150 a week. So the first thing that we always want to do is define our variables. So when we think about our variables, we have two things that we're considering here. We're considering our babysitting job and our tutoring job. So let's say that X is going to be our babysitting job, and let's make Y our tutoring job, okay? So when we look at our two different relationships here, our first relationship has to do with the number of hours we can work per week. I can work a maximum of 25 hours a week. So that means my tutoring job hours, or my babysitting job hours, and my tutoring job hours cannot exceed 25. My second relationship here has to do with money earned. At my babysitting job, I earn $15 an hour. That can be represented by 15x. And at my tutoring job, I can earn $20 an hour, which can be represented by 20y. I need to earn at least $150 per week, which means I could earn more, but I can't earn less. So I want to say that that is greater than or equal to 150. And actually working up to 25 hours, we could work 25 hours, so that one should be less than or equal to as well, okay? So now that we've defined our variables, we've written our system, now we want to graph both inequalities and see where our regions overlap, okay? So first we have x plus y equals 25. So I can graph this using my x and y intercepts. I know that both of those are going to be 25. So I have the ordered pairs. 0, 25, and 25, 0. I'm going to connect. Oh, that is a horrible straight line. Sorry, hold on one sec. That is going to be a straight, solid line because my inequality symbol is less than or equal to, okay? Now I want to pick a point and test it to see if it satisfies. So I'm going to pick the point 0, 0. 0 plus 0 is less than 25, so that satisfies my linear inequality, so I'm going to shade below this line. Now let's graph our second linear inequality. So we have 15x plus 20y is greater than or equal to 150. If I wanted to graph this also using my x and y intercepts, I can just plug in 0 for my different variables and see what I get. So let's plug in 0 for x first and figure out what our y value or what our y intercept is going to be. So I would say 0 plus 20y is greater than or equal to 150. So if I did 150 divided by 20, I would see that my y intercept is 7.5. So I'm going to come up here to 7.5. And then to figure out my x intercept, I want to plug in 0 for y. I see, 0 for y. I see that 15x is going to be greater than or equal to 150, which means that my x-intercept is going to be 10. Again, these two lines are going to have, or these two ordered pairs are going to have a solid line connecting them because my inequality symbol is greater than or equal to. I want to choose a point and see if it satisfies. So let's choose the point 0, 0. So 15 times 0 is 0, plus 20 times 0 is 0, so 0 is greater than or equal to 150. That is not true, which means that the 0.00 is not part of my solution, so I'm going to shade above my line. That's going to be my solution set. And I see that these two systems overlap, or these two inequalities overlap right here, so that's going to be my solution set. So let's get rid of everything I've already drawn. And let's shade in our solution set, which would be this region right here, okay? So that means I could pick any point in this region and it would satisfy both of these linear inequalities. All right, let's look at one more example together. So for this example, we want to earn at least $75 selling baked goods. We charge $5 for a bag of cookies and $15 for a cake. You cannot sell more than 15 items total, so considering bags of cookies and cakes, we can't sell more than 15 total. So we first, as always, want to define our variables. So let's say that X is going to be bags of cookies, and let's say that Y is going to be cakes. So now let's think about the two relationships that we have here. The first relationship has to do with the amount of money that we want to make. So we know we want to make at least $75. We know that we can charge $5 for a bag of cookies, and we can sell $15 per cake, and we want that to be greater than or equal to our $75 goal. Our second relationship has to do with the number of items that we can sell. We cannot sell any more than 15. So when I consider all of the bags of cookies and cakes that I make, I can't have any greater than 15, okay? So we've defined our variables. We've written our system of linear inequalities. Now I want to graph these two inequalities. So let's start with our green inequality. 5x plus 15y is greater than 75. So if I were to graph this, first, I could figure out what my two intercepts are. So to figure out my x-intercept, I can plug in 0 for y. So I would say 5 times x plus 15 times 0 is equal to 75, or greater than or equal to 75. I get that 5x is greater than or equal to 75. So x is going to be, or my x-intercept is going to be at the ordered pair 15, 0. I can do a similar process to figure out my y-intercept. I just want to plug in 0 for x. And I'm going to get that my y-intercept will be at 5. I'm going to connect these two ordered pairs with a solid line because my inequality symbol is greater than or equal to. And now I want to choose an ordered pair on the graph and see if it satisfies this equation, or this inequality. So let's choose the ordered pair 0, 0. 5 times 0 plus 15 times 0 is greater than or equal to 75. That would be 0 is greater than or equal to 75, which is not true. So I'm going to shade above this line. This is the region that satisfies my inequality. Okay? Let's look at my second inequality now. X plus y is less than or equal to 15. Both of these intercepts are going to be at the point 15. So x-intercept will be at 15, 0, and my y-intercept will be at 0, 15. Again, I'm going to connect these two ordered pairs with a solid line because my inequality symbol is less than or equal to. Now I want to choose an ordered pair and see if it satisfies. So again, I'm going to choose the ordered pair 0, 0. 0 plus 0 is less than or equal to 15. That is true. So this is the side of the line that needs to be shaded in. Last step, figure out where these two solution sets overlap. That happens right here between my two functions. So that must be the solution to this system of linear inequalities. So this shaded region right here is my solution set. That means any ordered pair within this shaded in region is going to satisfy both of my linear inequalities at the same time.